And, let's start with the panel. So it's about shaping the named data edge. And as you see in the picture, it's shaping, it's a delicate process. You can make things wrong, and then at the end you have no bowl, no soup in, and no lunch. So we don't want that. We would like to really go for understanding what is the shape right now in which we are. So I'm very happy to chair that panel. The approach that I took is the compute part, the compute edge, is a really prominent topic. We had a whole session yesterday on that. We see demos, we see a lot of pointing to the edge and the importance of that. The question is that just another use case? Is NDN just embracing edge and we have nothing else to think about? Or maybe there might be consequences. There might be deep fundamental architecture changes. We don't know yet. And how can we find out? Well, we asked the experts, and that was the approach. We asked them, what is the expected time to parity? Time to parity because we have an existing cloud. People can take the internet, they go to any of the cloud providers, they stitch together things. We have working groups on edge computing that is existing. And now NDN says, well, we have edge compute edge also. We would like to see how they compare to each other. And as one possible metric is how easy it is to onboard if you want to do NDN and edge. So that was the setup of the panel. And on the panel, I have two representatives of the NDN side. It's not so clear. I had underlaid a small image that you see. I have Jeff Burke, and in the order they are sitting here, professor at UCLA. He is one of the co-PI of the NDN project, currently working on an ICN-WEN project on augmented reality. Maybe some of that will come up in his presentation slides later on. We have next following Wang. She is at the University of Memphis, also in the circle of NDN researchers, having worked in the past on that and still today. And I discovered she had a seminar in spring on IoT, Edge, and NDN. So really on the focus of what we want to discuss today. Next we have Asit Chakraborti. He's coming from Huawei, and now we go to the people more outside of the NDN core team. He's a senior staff researcher there and has a lot of background in 5G, which is often mentioned also as an important use case for the edge. Before he was at Ericsson and Sun, and if I try to summarize, ICN, IoT, and 5G are topics that he will represent. And then we have Michel. He is with Data Machines Corporation, formerly at NIST for a long time, and heavily involved in the cloud. That is where he, I will not say play, but he is working with big data sets, with all the software that comes with that environment. And he's also involved in the bodies that try to standardize, to harmonize, bring people together, federation. I even heard in the preparation talks, grid is coming up again as a topic, a very old one. Not sure if you have heard of that, but some people have, and it was before the cloud existed. So edge and cloud, that would be my way of characterizing his profile. So let's jump into that. How is the panel organized? I have asked all the panelists to come up with this expected time of parity number. I will just flash it, and then we will ask each of them to explain what is their reason to come up with that number? How is the use case justifying these numbers? And we understand a little bit the different angles on the edged question. After that, we will have then 4 times time for challenges, recommendations. What do the panelists see as important steps for the community here to really go into the edge and embrace the compute part? At the end, 10 minutes left. So now for that, we can also have some interaction with the audience. Okay, so I think it is a cold start with just the numbers. And then this is what I got. Jeff said 5 years or 6 months. He will explain why. Lance said, I have to explain. As it was 2 to 4 years, and we have for Martial 2 to 3 years, but proof of concept could be done in 6 months. So there's some conversions, some question marks. Let's see how that plays out. And now that very immediate flip to the first slide. Is that okay, Jeff?
Sure.
So why did you come up with that 5 years or 6 month number?
Okay. So this is a slide from, or an image from a BBC Two series called The City in the City. It's about a city, two cities that share the exact same geographic region, and so that's how I'm going to explain the two different perspectives or the two different numbers that I gave. So we can go to the next slide. Sorry. I know we're supposed to get through these quick, so this was really just to explain why I have two numbers. So I really feel kind of part of two different overlapping efforts, one that's related to the research on NDN on the left, and one that's related to applications with or without NDN on the right. And so my sort of perspective from those two different camps, really, though they're happening at the same time, is quite different. I think we could get really interesting, very usable things for advanced application prototypes in, I think these are my old, well, no, these are new. In 6 months, with some specific focus on usability in comparison to existing tools, but for a very narrow slice of things. And then the research still seems to be quite a few years out unless we can put more energy and community resources behind the implementation. So to explain a little bit more, you'll see these numbers will change as I go from slide to slide as I think about it more. So kind of with the first hat, and this is usually Christian asks for things that are a little provocative. So the kind of NDN perspective is, well, NDN is still research. Stop bugging us about when it can be used. Go figure it out for your application. Read our paper. We know the problems you're going to have, and we're working on those, and we'll get back to you in a little bit. And the application developer perspective is, why can't I use NDN now to solve my exciting application problems and make these flashy demos or generate good photos for my PowerPoint decks or replace the cloud-based solution for X. And so taking these a little bit more seriously, I think the NDN research perspective to me is that parity is hard to talk about because it pits an experimental research code base or even just generally something that's still a research topic against tried and true, highly engineered solutions by very big companies and industry software teams. And so even at the edge, as soon as there's industry interest, we're again competing with engineering resources that we have trouble figuring out how to articulate comparisons to. And so the question is, what's the right metric for parity? And what are we really talking about? And I think some insight for that comes from the application side, or this desire to iterate, put things out there, experiment, which is actually a key part of the NDN project. The separation is a little artificial. And the truth is, it seems like most cloud-based solutions are really not ready to handle the edge. And we spent, 6 weeks this summer working every day with AR tools that are the best that are out there, and they do things in local environments, communicate the way that we want them to. They're not oriented towards edge-supported environments at all, and they're certainly not oriented towards the types of experimental applications that we're thinking of. So there's some low-hanging fruit to make what we can do already better, and I think the kind of time to running prototype is actually an interesting metric for parity, that we could do really well in providing solutions for people who are trying to innovate at the edge much more quickly. Oops, and then I think I had one more slide, but it was probably just a final number for these. So this is the perspective that I wanted to join the panel with, are these two hats, and ask a question on one side about, from the research perspective, really what is the right metric, and from the application side, try to answer it and say, how can we help people innovate quickly? And that time to experiment, time to prototype, time to product is something that if we can improve a little bit in NDN, we would be at parity with the best solutions for more advanced applications, I think, pretty soon.
Thank you very much. Perfectly in time. And I just asked then Lan to continue with her 2 slides.
Okay. Yeah. Okay, yeah. So first, I just want to follow up with Jeff. My comment is, what is the right comparison? Right now, if you compare what we do to industry's cloud-based solutions, of course, they're much, much more mature, but they're not solving the problem we are trying to solve, the edge problems. So they don't have good solution for that yet. So compare, what do we compare against? So we may advance even faster in that area than they do. So yeah, that's my first comment. My second comment is, it's hard for me to come up with a number as you want. You have 0, 1, 2, 4, 5, 8 plus years. So I thought for an hour and a half last night and couldn't come up with a number. So, but what I think I want to say is we have built a very solid foundation. That's why I put a foundation there. We have built a very solid foundation for building edge computing or edge services for different applications. But really, if we want to get something out that developers can use, we need a lot more funding. That's why I put the dollars there. A lot more funding to develop the libraries and tools, not just the high-level research. We need a lot of investment into the very robust, very reliable libraries and tools people can use. And we also need hardworking students. That's in the picture. We need a lot more students to develop the code so application developers can directly use. My third picture up there is, it means that the edge computing area, I think, involves more areas of expertise than we have right now, including storage, distributed computing, different application domains than we have in the current team right now, or people who are closely working with us. So we need a lot more collaboration with those with people in those areas, in those research areas, in order to come up with good solutions. Now, the last picture I put there is, I think, is similar to what Jeffrey was talking about. There are different types of problems. If it's a very simple problem, we may just need to write some libraries and find a good solution. I mean, using the library, we can directly map the application to a solution. But for very complicated problems, it will be much harder. And that's what I have in the next slide. So based on my experience, I worked on, I've been working on smart home using NDN, and also vehicular networking or self-driving applications. On the left side, you have the smart home application. I think for this kind of application, there's not a very strict requirements on, for example, timing or service level. So it may be 1 year for us to develop something that can that other developers can use. But if we were talking about the autonomous driving applications, we have very, very complicated situations. We have pedestrians walking, and we have different, we have many vehicles, we have different traffic signals. All these make the scenarios very complicated. In order to figure out what data to use, or what data to pull, what computation to do, and where the computation should be, all that, I think, requires a lot more research, maybe 5 or more. I can't give a specific number. But so my main point is, depending on the application scenario, there may be different time zones. Yeah.
Okay, thank you.
Yeah.
We are perfectly in time again. Summarizing quickly, one point made was that the IP edge, let's call it that way, might be not as glorious as it seems to be, and that would be one way to answer that question. And the other was an important element, the outreach, either to other communities, distributed computing you mentioned, and the learning more from applications. Yeah.
Yes.
Okay. I would like to continue with...
Okay.
Yes, exactly. You have one slide that you send. I put them. Yes.
So, I mean, yeah, I have only one slide, so it should be quick. I mean, so what I understood from Christian's question, parity with really cloud, not really edge, which is right now developing and I think not very mature yet. But with cloud, I think it's quite a lot of maturity already there, and a lot of development has already happened. So yeah, I mean, I feel that NDN has all the right pieces, and it's really great technology. So some of the negative things that I am trying to point out here is I mean, when you talk about parity, I mean, that's quite advanced, and how it went to that level. I mean, if you look at edge or anything, there would be some money trail. I mean, some industry will get interested and they will pull things. I mean, without that, I mean, it's very difficult to get all the resources and all the engineering and even research to happen in a short time. And I mean, who makes it really ready to use? I mean, research community cannot make things totally ready and just tell the industry, okay, here it is. I mean, take it and use it. I mean, because industry has to face customers. I mean, they will have to make it really ready for use in the real industrial scenario. So yeah, I mean, I feel that some industrial entity is critical for to come forward and pick up and develop some use case or a vision around NDN. So yeah, what I wanted to summarize is, I mean, ETP, why I say 2 to 4 years, I mean, 2 years is definitely possible. I mean, it really depends on what is happening in those years. I mean, if somebody is really going to run with it, I mean, even it's possible in less than 2 years. I mean, so I mean, time, I think is, I mean, probably it's hard to quantify in times. It's basically the actions that happens. But I definitely believe 2 to 4 years is possible. So coming to the other part of it, how much compute has to be there to solve the challenge? So my feeling has been, I mean, for quite some time is that, I mean, we know that NDN does things in a much better way in many, I mean, in solving many of these problems that we are talking about. But doing it better might not make a compelling use case. I think it has to do something new or something that with IP it's very hard to do, or it's so impractical to do that people don't approach those problems. I mean, and that would be the use case which will drive the adoption and which will eventually let NDN reach that parity. One thing, I mean, I think one thing that NDN community, I mean, the expectation is probably a framework to develop edge. I mean, the use cases are definitely important, but a framework which will allow people to innovate and add their components. I mean, that I would think is the most important at this point. And that would be my slide.
So what I got out a topic that Lan also mentioned, the money question. Who will pay for that? Lan said that we need more money for research, and you said this will be one of the driving forces. Maybe if I take the last line, should we then better talk about expected time to API? Is that the 2 or 4 years? Would you say this is reachable in 2 or 4 years?
Yeah.
Okay.
I mean, not just the API that is being provided by Indian community, but something that is ready for use in a deployment scenario for industry.
Okay, thank you very much. Martial?
I'm going to be talking to you about, a startup's favorite keyword, MVP, right? Minimum viable product. What we'll be talking about here is basically we can have a proof of concept ready in a month, like 6 months to a year, right? NDN is ready, edge computing is well understood, and yesterday I've seen a lot of very promising demo during the poster session. One of the things that I see happening for edge computing in particular is very related to the problem of geocolocation. So you're talking about you need to have control over the topology of the host location. The data and compute, in particular case, should be relative to one another. So for me, yes, we can develop a proof of concept within 6 months to a year. But I really think between 2 to 3 years, that's when we're going to have a closer parity with the other edge computing solutions that are already out there. Now, we're also going to talk about a draft document, right? It's about moving not only having the code available, but also having a draft for a standard at some point available to NIST. As a potential user of a product, and it has to go down to a product at some point, how do I get ready to a production-ready software suite? We know that commercially you have people like Cisco, for example, that are working on the hardware support. It would be wise, which was part of the conversation we had last night, to have some integration within some known cloud solutions. So I mentioned I'm the co-chair for the OpenStack Scientific Special Interest Group. I also mentioned that if we believe we're ready to move forward, it would be good to try to see if there is a solution to talk about a special interest group so that we can integrate NDN concept within other clouds. Basically do the outreach that is kind of needed for getting more money, more people, more resource. As users, how we use NDN? Well, we see a lot of people talking about using it as a container solution, on deployed hosts, right? So containers, great. So a ton of Raspberry Pi demo. One of the core difficulty that still needs to be solved for edge computing to be solved is latency and bandwidth. Because as much as we have proof of, I can run it on a 100 gigabit network, that's not a realistic use case, unfortunately, for actual edge computing in a car, on your cell phone, or something like that. We need it out of the test environment. We need it in a model that can be used. And so what does that mean? What that means is if you're using some device such as devices that are resource constrained, they also cannot run cryptographic methods, right? Those will be hard to integrate some of the more capable solutions. So controllers that can verify tokens, sign certificates, and we've seen API and conversation talk about that, needs to be presented. So I have a particular use case for NDN, right? So I'm thinking of NDN as a solution to help me work on a video analytics at the edge with multiple camera and camera synchronization with camera overlap. So to give you an example, you think about tracking a person over multiple view, okay, on a street view, or trajectory prediction. Somebody walks a certain direction, you want to be able to do analytics, try to understand where the person is moving forward. All of that is very interesting because instead of having to work at the IP level and try to figure out where I'm talking to, I want to talk to names. I want to have the information as a user to talk to data directly, better to talk to abstraction. I want to be able to capture to disk. I want to be able to stream. I want to be able to pre-process information at the edge. Pre-processing is very important. Data transfer is very costly. where we talk about 5G network, we talk about ad hoc networking, but all of that still means that you have to be able to have communication between all those edge devices. So what are we talking about? Well, we're talking about fog computing. We're talking about cloudlets. We're talking about NDN is really interesting for flow of information. You know, we call those interest, right? Because they are technically flow of data. Edge computing is also something that's already out there in many solutions. I'll talk particularly with OpenStack. OpenStack has an edge computing special interest group that's been growing. We have a fog. We have, you know, we have a lot of conversation about edge working with the networks. And we're talking about being able to deploy on data processor, data preprocessors. So where I'm going with that is that edge is about having small step processes being able to do large step compute, okay? So when you think about it, for my video example, I cannot stream 4K video on a network that gives me 100K per second. So what do I need to do? I need to be smart. I need to have pre-processing give me information that is pertinent for me. NDN is very useful for me at that level because I can tap into flow of information. But if I have geocolocation, then I'm able to work together. So basically, it's a problem of topology and host location. Thank you very much.
Thank you, Michel. In the first part, you had something similar like LAN, the communities, the outreach that is important.
Yes, sir.
And you had a very specific suggestion, integrate into existing groups.
Yeah.
Instead of trying to get people come to you, you go to the others, if I try to translate.
It's a mutual beneficial relationship, right? You
Yeah.
go to them, they see what you're doing, and they're going to help you by providing people and likely money. So, you know, we're trying to do the outreach. Would be a good time to try to figure out how to do it.
And the other element was you alluded to standards, to production-ready suits. I would guess that would happen in the next 2 or 3 years.
Yeah.
If you say that number, you expect that to happen in the next 2 or 3 years.
I agree.
And I think that would go together with the money. You would go probably for money if you can say, well, we will deliver in 2 or 3 years this and this and this. And for you, the standards would be part of that. The APIs for you.
Yeah, I mean, I don't see why not.
What would you do in such an envelope? What would you promise in 2 or 3 years if I take the number? Well, you didn't like the numbers. I understand.
I think we would, I mean, in 2 or 3 years, I hope we have a well-designed API for application developers.
Edge-specific API.
Edge-specific API.
Yeah.
But the underlying solutions to support that API, I think, would still require more research than 2 to 3 years.
Any wish that you would put in that basket of 2 or 3 years if you ask for money and that delivery that has the potential of outreach?
Is that 2 to 3 years in $250,000? I don't want to go back to the money necessarily, but just to do it once, is that 2 to 3 years of a couple of $250,000 projects, which is essentially the last 10 years, right? Or is it 2 to 3 years of multi-million-dollar investment of software engineering to try some things out? So I was just thinking of the example of the multi-camera video surveillance. So we have a multi-camera real-time tracking system that we've developed for something else. It's built on the robot operating system, and it uses a named message bus to communicate things. So it's not quite the edge, but you could imagine sort of edge processing scenarios using that same bus. That's something, in a year, we could have that running on NDN and release the underlying transport as another example to the ROS community, which is a sort of extensive open source robotics community. That's a major engineering effort that we know roughly how to do based on the experience that we have. And so I would love to see some of those kinds of efforts, but those are not really small scale research investments. Those are like, let's have a 5-person team go engineer this thing and release it in open source and see what happens. And I would love to see 4 or 5 of those kinds of efforts, kind of at the scale where the research community could support them. So it's not so big that it's unsupportable from the research perspective, but Anyway, so
Okay.
not a direct answer, but that's what I'd prefer.
But it's also related to money, and it's going to come down to that at some point, because you cannot move unless you're able to put the people there.
Right, and I'd say sort of engineering money, engineering and project management money.
Now I try to press you into that 2 or 3 years time frame, what you would like to put in. But the invitation for you was to come up with recommendations. How would you now suggest to the audience here or to the community what should happen to really make the edge happen? So, Jeff, would you start again with?
Yeah, so one recommendation, and I think just to put this a little bit more simply, is forego purity for a little while. And to see more experimentation that's about integrating NDN with existing systems and with making sure people can deploy it. So kind of this slide is based on those two hats again. Seems like the success of NDN at the edge is really about the ability to chain compute and data processing functions that are described by names, something that I know, Christian, your work relates directly to, but those are things that's really hard to do in the IP environment. It's really interesting for a number of applications. If we can solve security problems around being able to chain different compute functions easily from a developer's perspective, that would be great. And then we could stop looking at some of the Apache projects that make this very complicated and overwhelming to do. And the corresponding challenges below that. On the application side, it seems more like if we could transparently provision and communicate over the network we already have, NDN nodes, or, we could get a lot done that would look like and explore edge applications. And this is the less glamorous part of what seems like we need to do and what the team is already working on to some extent. And so I think there's both the sort of high-level ideas that need to still be developed about naming interoperable services and the data that moves between them, but then we also have to do the less glamorous parts pretty soon.
So is it just asking back these non-glamorous part, is it just a little engineering, or do you expect for the other pure part architectural consequences to explore? Is it just engineering or architecture?
On the left?
Yes.
No, that seems like a research.
Okay.
Still quite a bit to do.
Yeah. Okay. You also had a slide.
Yes. Okay. So yesterday we had a panel on security in edge computing. So I think that's one of the top challenges, but that panel has already covered it. So I'm focusing on the non-security part. So I think the first challenge our PhD students and other people can address is how we can support potentially a wide range of edge computing applications, especially since most of them are not well defined yet. They're very fluid. People are still doing application level research, how to do those applications. So how do we build the platform to support these kinds of applications? What are the building blocks, and how do these building blocks interact with each other? We don't have a concrete idea of this platform we're going to build yet. So I think it's very important to identify the major building blocks and the interactions between them. And then the second challenge I feel is, I think the computation aspect is a higher abstraction than the interest and data below it. And it's probably even higher than the synchronization level abstraction we have built on top of the interest and data. So we need to think about what is the right abstraction for computing in NDN, and what's the right API to provide to developers. First, it has to be data-centric. I don't want something that's going back to old host-based communication, right? You don't want to name to have certain hosts perform the computation. You want the computation to be named, not location-specific or host-specific. also from the application, applications may have some requirements for the computation. For example, they have to be done within certain time limit, and they may have some redundancy requirements. They want probably multiple computation devices to do the same computation and make sure that it's correct. I mean, they return the same results. So applications may have different requirements. We don't know yet, but there may be many. So how do we provide an API to support those requirements on the computation? So I think that is something the underlying networking needs to support. How do you support that? And the third thing that makes this challenging is computing requires different types of resources, not just CPU. It requires memory. The results require storage. So how do you make sure that when you when the application requests the computing, how does the underlying system satisfy or make sure that I'm going to satisfy those requirements or those resources the application requires? That's a very difficult problem, I think. So yeah, that's why I said this is one of the challenges.
Thank you, Dan. Asit, ready to take your slide?
Yeah, I probably took challenges in a slightly different meaning. I mean, not I'm probably mentioning more than just technical challenges and probably not a lot of recommendations there. So one thing, I mean, I still feel, but I'm not an expert on privacy and security, but I think there are open issues there. I mean, I do not know whether the current industry is willing to accept this model. So anything, I mean, more work from them to specify, like yesterday we heard some discussion, like more work from them to certify this, that this is enough, or this is at least enough for this kind of applications. I mean, those will be really useful. So in general, I feel that the receiver-oriented paradigm with low latency 5G and is a very good combination for edge computing, but it has even more security problems or security scenarios coming up. So basically, you have this execution environment that you have to support, and that has to be trusted by the service, and the application also has to trust it, and so those problems probably have to be solved there. And we are talking about on-demand function execution. We are not talking about like orchestration that happens in today's cloud or edge. Scalability and performance is an issue, but I don't think that's the biggest issue. We have success stories where people know that certain things are not perform as good as the other solutions, but still people adopted those because of other benefits. So like VMware is an example, and similar things probably will be fine. The other non-technical challenge, I mean, it's not an issue as such with NDN, but there is some perception that the edge computing itself is like is giving what NDN can give. Like it's like giving an NDN hop at very close to you. I mean, where you can cache, where you can provide service. So somehow we have to struggle with this. I mean, the main struggle with NDN is not a bad technology, but good enough technology. And how do you, I mean, encounter the good enough technology?
That's cool. So that rejoins your point that you really need to show something that IP can't do. Otherwise, you will always lose with that competition.
Right. I know it can do everything probably, but certain things which are so prohibitively expensive or so impractical that people don't even try to solve those problems. So those are probably what we need to pick up.
Thank you. That's it. Martial? You?
Yeah. I'm going to change a little from the topic I talked a little earlier, simply because, you know, one of the things that is kind of relevant to any form of data work is federation, in a way, right? My colleague, Dr. Bone here, is the chair of the IEEE P2302 on Cloud Federation. One of the conversations we always have on that type of effort is, at some point, you're going to need a service level agreement. At some point, you're going to need governance. It's very important in any distributed model. What do I mean by that? Well, am I an authorized user to access the data stored in your cloud? Can I use your compute? Am I on your edge? Can I make it work? You know, it's really come down to those type of questions, and it becomes more complex when you go back, and that's where grid computing comes into play, right? You know, when you talk about high performance computing, you talk about, you have a concept called a virtual organization. A virtual organization have models that enables you to define discovery, resource policies, access models. Members have roles and attributes. The same thing as a Unix user, right? If you work on any, you have a UID, a GID, and you have ACL, so you have access control layers. Those are very important for any type of data access. I know that there are solutions in NDL, but I feel like it's hey, I'm going to put a file out there. Everybody can, I'm giving you the URL, go for it. And that gets harder in problem where you're thinking, I'm working with the research community. I'm in Australia, I'm in France, I need to access data that is stored on an Australian server. What's the relationship from my country to your data? Am I allowed to access the data? Am I allowed to retrieve it, to pull it in-house? Do I have to use your compute? All of that is basically governance problem. And those need to be solved in order to have that conversation so that NDN can be brought to the broader research community as a model to enable data access. And we have a ton of data sets available in the public. The question is, how broad is public? What's my geographical boundary there? Now, devices are also very constrained. So same thing what I said earlier about, you only have so much resources on a small Raspberry Pi. Well, those cannot run cryptographic methods sometimes, right? Hard crypto. So it becomes difficult for them to, in particular, to participate in a federation or a virtual organization. And I have two extra topics, really, that I just want to put those questions out there, and then I'm going to be done. It's how can NDN be used to manage access to scientific data, just like I tried to explain earlier, over the network, regardless of geographic location? Same problem I just asked. And how is named data at the edge integrated or managed with the data in the data center and elsewhere? And those are, questions for you to think about, because at some point, in order to make the technology usable, I'm not the only person that's going to come out with those particular questions.
Thank you, all the panelists. You have been very kind to the moderator. I never had to intervene on the time. So we have a lot of time now for the questions and the interaction. The first thing would be to let the panelists maybe ask each other or comment on each other. As a moderator, I would have something that popped up in my mind when you alluded to Unix. Well, is NDN embarking in creating an operating system, a distributed operating system? That suddenly makes the whole game look different. And we're not talking about 2 or 3 years, it's 20 to 30 years. So is that maybe the right angle to take, or is it a dangerous angle? I don't know. For example, is that, oh, we need another app, we need another app, we need another app experience before we can really close on something that becomes either a standard, because there was that expectation. Hopefully we have in 2 or 3 years an API. If you continue to, we need another app, you will never reach that place. And it could exactly end up in that big operating system research that never ends. Is there a danger in that, or how can we protect against that? Can we have baby steps where at least we can then start to have other communities really start using it instead of waiting for 20 years?
So I'm going to go with the API answer. We have to have a standard, right? We have to have a method that defines the minimum requirements that an NDN needs to provide. After that, there are implementations. The implementation often go over the standard. Sometimes they have very specific add-ons that makes it into the API, and then they get backported into the standard. That's why we have versions. It's not easy to go from one to the other, but to answer your question more specifically, at some point, you need to have a version that makes it possible for people to have the minimum core technical functionalities in the standard to define an API, which can reach your point where, you know, the API is hopefully 2 to 3 years away for having something really functional. But we already have something right now where people can use it. Now the question is, do we have everything that we want, or do we have everything that is useful? And that's two different questions entirely. And then moving from one API model to the next is basically you know, version control and being able to have good documentation, and that's you know, good documentation makes developers' life so much easier.
I think the API we define is not specific to one particular application. Even the current API is not, right? So it's going to support a range of applications, and hopefully it's extendable to support some future applications that we haven't seen yet.
So if I may, I'm sorry. From the example I've seen in the demo, everybody is solving their own problem, but they develop their own API on top of the core API, but nothing goes back to the core. So at some point, how do we define what goes back to the core? What makes sense to add?
I think the process is the applications developers, they will give feedback to the library developers, what functions I need that's not provided by the library. And then the library developers will try to incorporate that. That's why we have the application-driven approach to develop the NDN platform. That hopefully, yeah, that's the way. The application developers should give feedback, right? And we have incorporated.
I guess the radical proposal, since again I'm sort of reverting to what I think Christian usually wants in panels, is that NDN is no longer a networking project. And that because what are we parity with what is the question. And I think if we're looking at how NDN competes with other IP-based technologies, we end up comparing NDN-based solutions not with IP. We're not comparing NDN and IP. We're comparing it with some number of other higher-level protocols and solutions. A good example that we've used internally is Google Firebase, which is not NDN, and it's not an architecture for networking, but it does a lot of things that we think of the network doing in a mobile application, let's say. And so this seems like a much longer discussion, but I think part of it's not even is it the API that we need, it's the mindset that this approach to communication requires new types of storage, new types of ideas about compute, new ways of looking at X, you know, we could go down the list of other things, and that by leaving it solely as a network architecture project, it makes it very hard to answer some of these questions. And so what I propose is that part of the parity conversation is parity with what, and what is that minimum viable product, not just as a network architecture, but a collection of interoperating components based on this data-centric philosophy that then is what we're suggesting is competitive. And maybe for IoT, it's really just the network architecture and a few little tools. And then for other things, it's a bigger suite of ideas and concepts and tools and so on. And so I think we're getting hamstrung sometimes by thinking of it just as network architecture.
I like that angle. May I use that to pass now to the last part, namely for the audience, and I'm sure there will be a lot of questions, comments. Who would like to start?
Well, if you want the radical ideas, I just start. I think I largely agree with the comment that Jeff just made and also Marshall's comment. I would not use the word standard, but I use a different replacement. I think we really need nothing to do anything about it. Some single person, single team can go. The rest of us have to help put together this well, clearly documented spec or something about how things work together. And like Michel said, we will have feedback, so we will have changes. That, however, should not stop anyone from trials. Mm-hmm. So this is bleeding edge stuff. I would borrow a statement from NSF. It's a high risk, high return. Mm-hmm. So we have to be willing to take that risk and just be aware, right? But if you don't take big steps, you'll never get there. I agree with the line, we need money, but give us 20 million. We are not, NDN team will not, my personal opinion, being radical, will not get this move forward a lot. Will not. We need the community. I think the interested parties out there, we haven't got all their help yet. We need to have some documentation to define this. So far, the only thing we have to be really precise, well, as precise as we make it, is just that interest data exchange spec. There's nothing about that, and that's what was missing to support things that the March wants to do.
So, if I may answer a little bit here, one of the things that I get exposed to as part of the our SIG is, I get exposed to a ton of very complex problems for high-performance computing, right? I don't have all the answers, let's be quite honest. I'm a normal person, right? But it comes down to we're able to be brokers. We're able to point people in the right direction and create those connections that makes it possible for members of a community, and that's exactly what we are, a community, to be able to learn from one another and to build on top of the requirements of one another. The trick is, and that's why I was pushing last night about outreach, unless we start seeing what other people need, we're going to design something that's for this community. And when you do that, you're basically designing something that's super functional, but and I'm going to try to find a good term for it, but that is basically used by a limited amount of people, right?
Called needless.
Well, I had toy projects, and that's worrisome, right?
Yeah, I agree with you completely. Like last night I said, I'm more than happy to talk to anyone who are interested in talking.
I pick up one word that you said, well, the library developers. So I asked the audience, please, library developers, come to the mic and tell us where you will be in 2 years. Who will be the library developers? I would like to see the person, the group, the whatever, experts. Well, we might have a problem in that case if nobody thinks they are in charge of that API, of that library.
You're talking about libraries, I have to stand up here. The thing I'm thinking, Christian likes to play with words. You're talking about parity with a T, but my concern is parity with a D. And we have to make sure that, we're talking about imagining getting millions of dollars to develop NDN into something awesome in 4 years, and we're thinking about creating parity of that with a parity of what IP solutions are today. The parity is, the cloud is logging in the Gmail, right? And that can't do edge computing or something. But there's already a lot of work based on current IP to do things that do work at the edge. And when we're comparing parity, we can't do it against the parity. You have to imagine what we'll be comparing NDN against in 4 years when existing solutions have responded to the needs of edge computing, like Jeff talks about Firebase. I can imagine ways in which they could develop that so that it would have local responses and that it would work at the edge. I'd like to hear from if it's Q&A, I'd like to hear from the panel, instead of thinking like an NDN researcher, what would, if you were working for Google with unlimited money, How would you solve this problem of computing at the edge using the existing solutions? And then you would come to us in 4 years and say, here's what we can do. Is NDN better than that? That's what I would like.
If I can at least start on this one. I don't know what I would do as Google, but I've thought a lot about that and was writing to Alicia about it based on just our experience this summer in doing essentially a local AR experience where we needed to deal with, a set of mobile devices, a set of external sort of support machines, content, code, so on. And I was thinking about, because we used the sort of, I wouldn't call it best in class, but apparently best in class middleware solution for communication between the mobiles that was supposed to work in a local environment. It was terrible, and it had no real sort of, in terms of performance and APIs and other stuff. And I was thinking about, well, if we were to rewrite that, knowing what we know now, what would we write as this sort of local communication platform that also had some other features we were interested in? And it looks a lot like NDN. I mean, in the sense, I think even though it's happening in a research context, or started in a research context, the principles are coming from the deployed internet and experience at scale. And so it maybe a big organization would do something different, but I'm not sure it would be that different, right? I mean, part of the reason that NDN was originally interesting to me is it seemed to do a lot of things that distributed middleware from 10, 15 years ago did, but without the IP mess, like the gluing it to the IP that was most of the problem. So I guess I think we're doing some of what you're asking. What we don't seem to be doing much of is figuring out how to compete or compete in terms of the open source code base with the other solutions that exist that were so frustrating or are so frustrating sometimes to use in certain cases. And so behind the push that I've been trying to make for making easy deployment of the code that we do have and configuration is that I think there is a very competitive solution there. The reason it's not competitive is because deployment is hard. And so we don't look any better than the other solutions. So it's not exactly what you were asking, but I do think we're competitive with those things that are nominally edge solutions now. We're just not as easy to deploy or use.
If I understand Jeff right, I will try to say it in a different way. There's engineers, good engineers know how to build the system. It's follow the same set of principle. Whether you tweak it to be under the IP header or otherwise directly under NDP, where you NDN, this is just the minor details. The principle, people actually realize is all going in that same direction. Look at the QUIC. What's the QUIC? QUIC is the application level unit of data. It's just that they are now still constrained to the point-to-point communication because of UDP or IP.
One last thing, just the Milcom, the set of papers that are going to be at Milcom in October, one of them is just, hey, look, these things that work in the cloud, that are good design patterns for the cloud, work pretty well in a tactical environment if you swap out IP, right, if you don't have this host addressing. So some of it is there.
Yeah, I think, those big companies, they can afford, they can build their own network. They can put content caches anywhere. So they can engineer their solutions even if the underlying support is not good enough. They can put in as many resources as they want everywhere. But the problem is if somebody who is not Google, who wants to develop something like this, what do? They don't have any way to do that.
The same statement can be said many years back about IP. That was, I remember ATT told us their interest, the revenue or something, multiple billions of dollars. They said, how can you compete with us? Even
Trying
though
to avoid that we end up
running.
with lamenting, I would like to come back to the last thing. As a library developer, do you know whom to talk to? Would these people working on libraries come together and attack that API for the edge? So if that would be an outcome of today, realize there's an opportunity, come together, would you know who to talk to? are the peoples here. Hopefully at lunch they will talk to you, and that comes together.
We have a lot NDN lib mailing list sent to there.
Can I ask, Christian, can I ask you a question about what you mean by API? Do you mean an orchestration level kind of thing? Like what is API? We have lots of ideas for APIs, but what's in your API for edge computing? Like what are the parts of it?
For me, it would start with that you can express what you would like to have as a result. So in the name function spirit, you say, I would like to apply this function to that data. And already agreeing on the expression format, a small library that hides the way we map it to any current existing prototypes, that would help a lot. People could start thinking in terms of, oh, I have now that possibility to express things that I couldn't before. That would show them, it would communicate what is possible now. And we could still, under the hood, do our research games, try different approaches, but already expose that there must be something where application writers have an easy way to invoke edge functionality. So that would be a first step. It doesn't have to be a very rich API, but it starts somewhere. And for me, this expression, how you express result production that you would like to outsource to the edge, that would be a beginning.
So just as a, not to monopolize the time, but just as a question for the audience and for you, what would be interesting would be to see a description or a block diagram of what some whole releasable unit of software would look like. Like,
Absolutely.
or is what you're asking for that we have for example, a Docker container that has all the NDN stuff, all the configuration, all the things that need to happen, that runs on any node that we can run it on, that presents that API over the network, and is already configured to find other Docker containers in the same network, sort of speaking informally, and then has hooks into well-known compute engines that sit on top of it that people already know. I think what we need to know to some extent is what is the module of experimentation that would be interesting for other communities. And is it that or is it something else? Yeah.
I'll tell you that's actually a really good solution to get people to play with it more also. It comes down to the question of how many people outside of the community can play with it. Having something like that means that you can say, hey, if you want to try it, here's a container, play with it, extend it, do what you want. And I have a few nodes at home that are for experimentation, right? It runs a Kubernetes cluster just for fun, right? But that's exactly that. You have people who want to basically try things on their own in order to give themselves an idea. Sometimes it's really hard when the Docker makes one thing very functional for people. It made very easy for people to test things because you can do a Docker pool.
Shouldn't go now to Docker advertising.
Okay, yeah, sorry.
It's nice.
I like Docker.
I like to. Definitely, that would be a minimal viable product, and API discussion would be nice.
It would just be great to get that input on that. Yeah.
Now I have to start wrapping up. One more last question before we really wrap up.
Very
please.
practically used, say, we have an ACM group and student group. They are very active. They can hosting their own hackathon. They can do technical kind of lectures for themselves. However, if I want this NDN, right, to introduce to them what the resource I can use, they thinking about the developers building block, these blocks. There is a host model, the paper on that, right? How, right? These are the group that if I want to check them interest on developing anything or try it out for applications, right? What are the resources I can use for them? That's just my question. It may not be relevant to this panel. However, I think this is the chance I can get a lot, experts' response to
I don't
that.
want to take Jeff because, the website has a lot of interesting videos. There's still things missing, but the website is a good resource to get started.
Okay, so thank you very much. Let's thank the panelists.